Just a little background on what we're going to cover in my part of the presentation. So we're going to talk a little bit about, uh, we're good with acronyms, so HLU refers to our Husky Lloydminster Upgrader facility. I'll give a little bit of history behind Husky and the upgrader in Lloydminster. We'll talk about our OTS resources, what we use at our site, where we see our program going forward. As with most systems, there's that continual change. We don't want to see it drop off the radar, which a lot of times it happens, and then we have to rejuvenate it again. So how do we sustain the use of an important tool and investment like an OTS system? I'll talk a little bit. Aviva's been a key player through their previous incarnations as well in our OTS system at the upgrader, and our continuing relationship with them through their customer first program, and question and answer process will be as part of the panel there. So Husky Energy actually was founded in Cody, Wyoming back in late 30s. So a refinery was down there, and at the time it was the Lloydminster area, right on the Alberta-Saskatchewan border in Canada, had a product that was ideal for the rail systems. So the decision was made at that time to load that refinery up on rail cars, move it up to Lloydminster, reconstruct it, and that refinery, not in its original incarnation, but we still have that refinery in Lloydminster as well. Later on, that heavy product wasn't deemed to be the ideal product for refining, so the upgrader came into a concept, and that was put in place in the early 90s to convert that heavier product that was originally needed for the rail system into a lighter crude that the traditional refineries were used to dealing with. Husky deals with operations in Western and Atlantic regions of Canada. In addition to that, we have holdings in the Asia Pacific region, as well as properties in the United States as well. Our integrated corridor. So we've looked, right from that beginning, those resource plays where the products coming out of the ground, thermal in our Lloydminster area. So our steam-assisted gravity drainage projects, significant part of our production right now. Right around that Lloydminster area ties directly into our upgrader facility. So great synergy there for us. So I mentioned that we're converting that heavy oil from our area into the lighter synthetic crudes that can be used in other refining processes. That ideally suited for our refinery over there, which deals with the asphalt, a lot of that heavier side. Lighter side moves over to us, and we're able to create that synthetic from it. Even what were considered waste products at the time, sulfur, has become an integral part in fertilizers. So that's just helps in efficiencies with our products. Even petroleum coke, the worst of the worst that comes out of our products, still has a use out there in industry as well. So going back to kind of the even CAD days. Now, I'm not going to say CAD didn't exist, but this is what our operators at the time had to work with. This was the scale model that was built for our upgrader facility, and that was used by our original operations staff going through and designing their operating procedures and strategies for operation, getting scale. This model is still used. Currently, we have turnaround scheduled for this year, actually in a couple of months. So we have vendors coming in, a lot of equipment vendors for locations of cranes, how they're going to move equipment in. So it's a nice kind of visual hands-on tool that's still being used. So just a variety of the processes. You may notice one or two spots where a piece of equipment has been removed. The model hasn't been maintained, and maintenance, whether it's a model, whether it's a simulator, is a key component of a valid system. But as people have retired over the years, they maybe had a significant attachment to a piece of equipment, and so a piece of equipment may go missing from the model and sit on somebody's shelf. So as I mentioned, the upgrader facility in the early 90s, at the time, management at site saw this as being a significant piece of equipment to prepare our operators to operate the facility. And so the implementation of simulators was right from the beginning. Initially, simulators at the time had their own challenges. They up and down. The reliability was a little bit shaky. Over time and through incarnations, that's improved. And then it's been that maintenance of the systems has really been the biggest challenge over the years, to make sure that the system reflected on the simulator equals our live system. Going back to one of the reasons why the simulator was seen as an important step forward was, and anybody that's worked through that process, maybe went through this same training process, was your panel training consisted of job shadowing. And so you've got the operator that's running the facility. He's looking for the plant to run as smooth as possible. You as the trainee are waiting for something to happen so you can really learn how to react to those. So that really stretched out the duration of training in this manner. So you could really get the opportunity to see and react to those situations when they occurred. So around that time, we were looking at probably 9 months or longer, depending on the situation, depending on the process going in. At our facility, all of our operators basically come to us having completed a 2-year preparatory program to acquire their STEAM certification. So we've got that as a base level. Then they'll learn their outside process. They'll stay in that process depending on the complexity of that area for anywhere from 3 to 5 years before they're ready to move into a panel position. So we want to really make sure they have a good grounding on that field application of the process. Moving into a blended process, so that's looking at using the simulator in conjunction with that shadowing at the panel. It shortens down the time a little bit, but the challenge there was the amount of time still that was required, even using the simulator. But we have four teams. We're run 2 shifts a day. Each team would run that training themselves. So you had to have a significant population of well-seasoned operators that are able to pass on that knowledge and be able to significantly use that OTS as a tool in the training. So we saw that as a little bit of a restriction. So that's where we moved on to the current system that we're following, which is more of a school-based. Our current attrition is roughly about 5 operators a year. Most of that are operators retiring, leaving the company. So I mentioned our new operators coming in, starting at the bottom and moving their way up through developing those skills. So our school will catch up to match our kind of our own internally determined number of 3 trained panel operators on each shift. So where we see a weakness in that, we'll rotate people around from shift to shift. But our target is to maintain that. So across the 4 teams, we'll look for candidates that have demonstrated an interest, an inclination towards moving up to that panel position and set up a school where we focus the training there. And this training is directed towards making a panel operator. We don't just focus on the simulations, the upset conditions, we definitely cover those as well. But just from the routine maintenance and through sitting through some of the sessions here, looking at how machine learning and things like that can be incorporated into the amount of time that an operator is monitoring the system. Having other tools available to help with that definitely seems to be an opportunity for us. But currently, that's our approach is kind of on a proactive basis is what does that monitoring of the system currently look like for us? How can they identify those conditions? How can they correct those conditions before they move into more of a reactive situation? But that reactive situation is going to happen. So we want to make sure that they're trained to be able to deal with that. So as we're running them through the training, a lot of the simulations will be pretty standard, pretty routine. Then as we advance in the training, then we start making those a little more complicated, increasing that stress level within that training development, because that's when really the rubber's going to hit the road, when you want to make sure. And the simulator is the ideal situation to do that. You don't want a situation out in the facility where you're doing a job shadowing situation to train somebody. You want to be able to do it in the safe confines of something like the simulator. Our schools consist of a qualified trainer and qualified trainer, so that's a significant training in their background. They're familiar with the simulator and they're able to run the trainees through those systems that they need to know. We like to make sure that our trainees are comfortable with running the simulator as well, because that's part of that maintenance of their skills as well. When they have training sets or time available to them, they can come in, fire that simulator up, run some of those simulations themselves to ensure that their competency level is maintained. We originally started with one simulator because of the use requirements, maintenance as well. We built a second one. Definitely has helped with our ability to make sure that we have the simulator available to be accessed by the operators when they need it. We don't internally have a lot of process automation resources available. So we make use of Aviva's customer first agreement. So that allows us the access to the engineering expertise at Aviva to go into the design and upgrading and updating of our simulators, which really allows us to get the best of both worlds in the maintenance of our simulator. So the issues were to improve the efficiency of developing competent panel operators. The challenge, as with most organizations, the time and the money that goes into it. Fortunately for us, we've had simulators basically from day one, so it wasn't any arguments that had to be made to bring them in. You know, how we have resolved that, multiple trainees, our OTS system that duplicates at a high fidelity level our live system. Make sure that our operators have the monitoring skills that they currently require. and make sure that they come out with the competency that they need to jump right into that operation of the live panel. Thank you.